Hello everyone, welcome to the networking lab. Today we're going to do a full hands-on lab configuration on the topic of NAT and PAT in Cisco Packet Tracer. Here's what we are going to cover today. We'll start with a quick explanation of what NAT is and why we need it. Then we'll compare all the three types of NAT. Following, following that, we'll jump straight into the Cisco Packet Tracer and we'll build a topology and then configure static NAT, dynamic NAT, and PAT one at a time. And then we are going to test and verify each one of the category. And we'll finish with the verification and troubleshooting commands that we need to diagnose the NAT issues fast. So let's get into it. So NAT stands for Network Address Translation. It's the mechanism that lets your router translate private IP addresses, the ones that you use inside your network, into public IP addresses that work on the internet. The reason NAT exists come down to one problem: IPv4 exhaustion. There are only about 4.3 billion IPv4 addresses in the world, and we ran out of all unallocated public IP back in 2011. So NAT is what lets billions of devices share a small pool of public IP addresses. So here's the flow. Your private IP addresses on on your internal PC. When it sends a packet to the internet, the packet hit the router. The router swaps the private address into a public address before sending it out. When the response comes back, the router translates it back and delivers it to the right internal PC or device. From the internet's point of view, all your internal devices appear to coming from uh, just one public IP. Your internal addresses are completely hidden, so that's also one of the benefit. So, so these are one of like three benefits. One is just conserve the public IP addresses. Another is to hide the internal addresses, and then the third one is to give you flexibility s- such that if you if your ISP internet service provider is changed, you don't need to renumber your internal network again. Okay, so let's compare the different types of NATs. First one is static NAT. Static NAT is a permanent one-to-one mapping. One private IP address always translates to the same public IP address. You use this when you have a server, a web server, a mail server, or anything that needs to be reachable from the internet at a fixed address. Another one is a dynamic NAT. Dynamic NAT uses a pool of public IP addresses. Internal devices gets assigned a public IP from the pool on first come first serve basis. If the pool runs out, new connections are dropped. And the third one is PAT, which is port address translation, also called NAT overload, is by far the most common type. Many private IP addresses all share one public IP addresses differentiated by the port numbers. So here's an example. So we have two internal IP addresses. Both of these addresses are translated to .5 public address, but the only difference is the port number, which is 1025 for this address and dot 3000 for this address. And and that is why we called PAT as many to one, because multiple addresses are translated to just one address. In the case of dynamic NAT, it's like there are multiple internal IP addresses, and then there are multiple public IP addresses. And in case of static NAT, it's just one-to-one NATing. So here's what our topology is going to look like. On the left hand side, we have our internal network, 4 devices, PC0, PC1, PC2, and the server. They are all connected to a switch, S1, SW1, and the switch connects up to our Cisco router, which is our NAT gateway. The router has two interfaces, fast Ethernet 0/0 fast and fast Ethernet 0/1. 0 is for internal and the 1 is for outside. On the right hand side, we have simulated the internet. There's an ISP router and a web server. The most important concept in this whole lab is the interface connected to your LAN is NAT inside, and the interface facing ISP is NAT outside. So you have to declare both on the router, or otherwise the NAT will silently fail. The traffic just won't translate. So let me build this in Packet Racer now. Okay, so now let's uh, try static NAT first. So I've created a network. So this is the internal network with 192.168.1.0/24 network. And this is an inside zone, and this is the outside zone. So now we have to map our internal server, which is 192.168.1.100, to a public IP address 203.0.113.10. So let's get started. We'll go to the router and go to terminal, interface, fast Ethernet 0/0. You have to mark it inside first. So I'm talking about this interface, so which points to the NAT inside zone, and this is the outside zone for this router. So as you can see, fast Ethernet 0/1 is for the outside zone. So with this IP NAT outside, and now this tells the router which side is for private IP addresses and which side is for public IP addresses. You only need to do this step once, and it applies to all the three NAT types we are configuring today. So step 2, we have to go to the terminal. Now we have to define the netting here. Configure IP NAT inside source static, as we are configuring static route 2.168. Oh, sorry, it's not static route, it's static NAT. So 192.168.1.100. So I'm statically configuring this server's NAT IP to 203.0.113.10, and that's it. Now this means that the IP address of this server has a static public IP, which is 203.0.113.10. So since this network is 203.0.113.10, 0.113.0. This means that routers, this interface can directly ping to my uh, server. So let's try that. Now, if I try to ping 203.0.113.10, it should go through. Okay, so now let me show you the command to see the network translations, the IP NAT translations actually. So you can see this. This is the internal IP address of our web server, a server inside the zone, and we have a static public IP address of this address. Okay, so we're done with the static NAT. Now let's move to the next configuration, which is dynamic NAT. This time, instead of a fixed mapping, we'll try internal pieces pull public IPs from a pool dynamically. So there's 3 steps. Step 1 is to define an ACL that identifies which internal devices are allowed to be translated. Step 2, define the NAT pool. It's the range of public IP addresses to assign from. And step 3, bind the ACL to the pool that we have already created. Okay, so let's get started. So we'll jump into the router terminal and create an access list first. On 168.1.0.0.0.255. So this matches our entire 192.168.1.0/24 subnet. And next is to create a pool, IP NAT pool, my pool 203.0.113.20, 203.0.113.25, net mask 255.255.255.0. So we are creating a pool called my pool with 6 public IP addresses from .20 through .25. So a maximum of 6 devices can have active translations simultaneously. And next is to bind. So IP NAT inside source list 1 pool my pool. So we bind together the access list 1 to this pool. So this command connects everything together. It says that take traffic matching X ACL1 and translate it to my pool. Okay, so now if I try to ping from this PC, which has an IP address of 192.168.1.10 to this router, which has an IP address of 203. 0.113.1, it should go through. So let's try. Sorry, I forgot the IP address. 0.113.1. 0.113.1. Okay, yep. So it went through. Now let's check on the router to see the network, the NAT translations. Show IP NAT translations. So you can see the the IP address has been successfully natted. So we are done with the dynamic NAT configuration. The next one is PAT or overload configuration. And now the one you are going to use most in the real life is PAT, port address translation, also called NAT overload. This is how your home router works right now. Dozens of your devices, for example, phone, laptop, TV, tablets, all sharing a public IP, and the router keeps them separate using port numbers. The configuration is almost identical to the dynamic NAT with one key difference. You add the word overload at the end, and instead of a pool, you point it at an interface. So if you have previously configured dynamic NAT, we need to first remove the dynamic NAT. Okay, to remove the dynamic NAT, we need to go to the router and configure terminal, no IP NAT inside source list one pool and my pool. Wait, something's missing. IP NAT inside source list. List is one pool and my pool. Okay, yeah. So now we need to configure the PAT. Need to create an access list. One permit. I think the access list is already created, so we don't need to create the access list again. IP NAT inside source list one interface and the name of the interface, which is 0/1 and overload. So that's all it takes. So we're saying that take any traffic that match with ACL1 and translate to the IP address of fast Ethernet 0/C1, our public interface, and use port numbers to tell the different devices apart. So let's test it. Ping from all three PCs simultaneously. For example, so let's ping the same here, copy, ping the router. Okay, it went through. Now ping from the second PC. Wait, paste. Okay, it went through. Ping from third PC. Paste. It went through. So now if I can check on the router, show IP NAT translations. So you can see all the three PCs have translations. They all are using same public IP addresses, which is 10, 203.0.113.5, but the only difference is the port number. So, so you can see this this IP address of PC number 2 has an IP address of 192.168.1.12, and it has been translated to 1024 port number, but the IP address is same as what this PC got translated to, which is 203.0.1.113.5, and the port number is 17. And similarly, the third PC, which is 192.168.1.11, has been mapped to 203.0.113.5, but port number 2, port number 1, port number 2. So these are for all four ICMP packets. Now let's look at how we can do some verifications and troubleshooting. First and most important is show IP NAT translations. This show you the entire active translation table inside local address, inside global address, outside global, outside local. For PAT, you will also see the port numbers. If this table is empty after you generate traffic, the NAT isn't translating. So check your ACL and pool configuration. The second is show IP NAT statistics. So this is how you'll be able to see the hits and miss counts. How many packets were successfully translated versus how many packets were missed. It tells you which interfaces are marked as inside and outside. If your interfaces that are inside and outside aren't showing here, so there's some problem in your configuration. Third, debug IP NAT. So this prints a real-time log of every transaction happening on the router. This command is actually really useful for seeing exactly what has been translated or what's being translated in the real time. Fourth is clear IP NAT translation star. So this flushes all dynamic entries. Use this when you have made a configuration change and want to see fresh translations without waiting for the idle timeout. And the fifth is show running config pipe include NAT. So this filters the configuration to only NAT related lines, and it's the fastest way to confirm your access list, pool, source statements all in one place. So yeah, we are almost at the end. Yeah, so we have completed our full NAT and PAT lab in Cisco Packet Tracer. So thanks for watching and subscribe and hit the like button if you like the video. Thank you.